Hello FLL teams. In this video, I'm going to describe how to make and use a basic MyBlock. This is the second video in a series of videos that I hope will allow teams to take their software programming to a higher level. This video assumes you watched our first video, Introduction to Variable Blocks in NXT-G. So if you don't understand variable blocks, I recommend watching that video before this one. Using a MyBlock that you have created is similar to using a built-in block such as the Move block. Once you've made a MyBlock, it will be available under the Custom tab here. When I hover the mouse over the MyBlock symbol, you can see all of the MyBlocks that my team has created over the last few seasons. Let me put the line follower block that I designed onto the beam. MyBlocks look like normal blocks, except that they are aquamarine in color. This takes a while. You can see my line follower has several inputs and even some outputs. For example, the input third from the top specifies the distance in millimeters that the robot should follow the line. The input just below is a logical variable, which tells the robot whether to follow the left or right edge of the line. You'll notice the MyBlock also has outputs. For example, this one in the middle is a logical variable that will be true if the line follower was unable to find a line during its initial search. Having status outputs on our line follower MyBlock gave us the capability to detect and even react to unexpected conditions, such as would occur if the line was never found. Just like normal blocks, you can place them on the beam and you can assign values to inputs by either running a wire from another block or by simply typing in a value in a field. The advantage of using MyBlocks is that you can make blocks custom-made for your robot, and you can make your robot do things that built-in blocks such as the Move block cannot do. If you double-click on a MyBlock placed on a beam, you can see the blocks that were used to design the MyBlock. In programming lingo, MyBlocks are equivalent to subroutines or functions. They are pieces of software code that do a specific task that you can run from your main program or even from within another MyBlock. MyBlocks can have inputs and outputs, but they don't have to. Since all variables are global in NXT-G, data can be passed into and out of MyBlocks using either global variables or with inputs and outputs. If you want your MyBlock to be flexible and easy to use, the best way is to make your MyBlock have inputs and perhaps even outputs, just like a normal NXT-G block. A good reason to use MyBlocks is when you find that you need to repeatedly do the same task, consisting of a set of multiple blocks. For example, a good use of a MyBlock would be if you had a block which you use in several of your missions, such as a line follower. Suppose in 2 different missions, you need to follow a line for different distances and using different edges of the line. Rather than specifically designing 2 line followers for each of the distances and edges, it makes better sense to make a single line follower MyBlock that has an input that allows you to specify how far to follow the line and which edge to follow. If the 2 instances of line following appear in the same program, then you will save a lot of memory. Using MyBlocks can make your programs occupy less memory space on your NXT brick, since a MyBlock is stored in memory only once, even if it is used by your program 10 times. This is a good thing because the NXT brick has a very limited flash storage space. In order to demonstrate how to use MyBlocks, I want to present a design that is similar to something our team used 3 years ago when we first learned about MyBlocks. I will demonstrate how to make a MyBlock that will allow you to command your robot to drive a distance which is specified in millimeters. Our team has found that specifying movement in millimeters rather than degrees or rotations really speeds up our mission development and improves our robot's accuracy. The MyBlock I'll create will have 4 inputs: power, direction, distance, and steering. It will make use of the built-in Move block, but it will use millimeters to specify the distance instead of degrees or rotations. Our coach has taught us a good method to use when creating MyBlocks, which allowed us to avoid some of the pitfalls that cause a lot of lost work and time. In order to make a MyBlock with this method, we first make what our coach calls a pre-MyBlock. We store all of our team's pre-MyBlocks in one directory in order to keep track of them. Once that pre-MyBlock is tested and proven good, we then turn it into an actual MyBlock. But we will make sure that we preserve the original pre-MyBlock code in case we need to change the MyBlock at a later time. The MyBlocks themselves will be generated and stored in a separate subdirectory. The pre-MyBlock serves as an optimal way to test the MyBlock code, so it is beneficial to preserve it. The name of our MyBlock I will create in this video will be GoDistance, so I'll name the pre-MyBlock GoDistance_pre. So let's start by creating a new file which we will name GoDistance_pre in a subdirectory called pre-MyBlocks. We're going to be using a move block inside of our MyBlock, so let me grab one from the common menu and place it on the beam. Notice how the move block has several options for duration: unlimited, degrees, rotations, and seconds. In order to get the most accuracy out of the move block, it is best to use the degrees option. So that's what we'll use here. Our motors are connected to ports B and C, so we can leave the default values. Also, we're going to want to make sure that next action is set to brake rather than coast in order to ensure accuracy in our movements. The values for power, direction, distance, and steering don't matter since we're going to provide those as inputs to the move block, which will override anything we might type in any of these fields. For convenience, we want to tell the MyBlock how far to go in millimeters, but the move block needs to be told how far to go in degrees. Therefore, our MyBlock will convert the input values from millimeters into degrees. The number of degrees to rotate the motor depends on the wheel radius of your robot's drive wheels. Think about it. If your robot has really big wheels, your robot will go further on one revolution of the wheel than if your robot has really small wheels. So our MyBlock must be told what the wheel radius is and must use this to calculate the number of degrees to rotate the robot's wheels. Wheels are circular, so using the formula for the circumference of a circle allows us to see how far the wheel will travel when rotating one revolution, which is 360 degrees. The formula on the screen tells us that one revolution of a wheel will move the robot 2 times pi times the wheel radius. One rotation equals 360 degrees, which equals 2 times pi times the wheel radius. Dividing by 360 will give us the distance our robot moves if our motor rotates only a single degree. Distance 1 degree equals 2 times pi times the wheel radius divided by 360, which equals pi times the wheel radius divided by 180. We will define a variable called desired distance that will be how far we desire our robot to move in millimeters. To find out how many degrees to rotate the motor in order to travel a number of millimeters specified by desired distance, we can use the previous formula and set up a ratio as shown here between the 1 degree case and the desired distance case. Degrees to go divided by desired distance equals 1 degree divided by pi times the wheel radius divided by 180. Solving for degrees to go, we get the following equation. Degrees to go equals 180 degrees times desired distance divided by pi times the wheel radius. It's okay if you don't follow the math. It's kind of tricky. The important thing is that you understand that we can use this formula to compute how many degrees the motor needs to rotate in order for the robot to go a desired distance in millimeters. You'll need to measure the radius of the drive wheels on your robot in millimeters for use in this formula. Of course, this formula assumes that the motor drives the wheels directly without any different size gears between the motors and the drive wheel. Okay, so now that we're done with the math, let's start making the GoDistance MyBlock. The first step is defining the variables we'll need within the MyBlock. Our MyBlock will have 4 inputs. Distance, a number variable which will be specified in millimeters. Power, a number between 1 and 100, defining the power to run the motor at. DIR, a logical variable which will define whether our robot's motors will spin in forward or reverse. Steering, a number between -100 and +100, which allows the robot to drive in an arc. Setting it to 0 will make the robot go straight. In addition, I'm going to create 4 more variables with similar names to these, except I'm going to put the prefix in before the names. In distance, in power, in DIR, and in steering. These 4 variables will be initialized in the pre-MyBlock, but will not be part of the actual MyBlock. They allow us to give initial values to the MyBlock inputs for testing and allow the creation of the input ports when we generate our MyBlock. Next, I'm going to define a number variable called wheel radius, which will hold the measured value in millimeters of our robot's drive wheels. Next, I'm going to define a number variable called C180/pi, which will be used in our calculation and which will be set to 180 divided by pi, which is approximately 57.296. A constant block could be used instead of a variable block for this, but I prefer using variables. Okay, now that the variables are defined, let's get on with the process of making the pre-MyBlock. The first thing that we're going to do in our pre-MyBlock is initialize the 4 variables with the in prefix. To do this, let me start by dropping 4 variable blocks onto the beam and initializing them with default values. All 4 blocks should be set to an action of write in order to initialize them. The first variable to initialize is in distance, and we'll set the variable block's action to write, and then we'll initialize it with the number 1000, which means we'll be asking our robot to drive 1000 millimeters, or 1 meter. Once the MyBlock is created, we'll be able to change this to whatever we desire, but for now, we must give the variable a default value for testing. The second variable to initialize is in power, and we'll set the variable block's action to write and initialize it with the number 50, which means we'll be testing our pre-MyBlock with a power of 50, which is half speed. The third variable to initialize is in dir, which is a logical variable which we will initialize to true, which will make our robot go forward, assuming our robot has its motors installed in a forward direction. Note that robots could be designed with motors facing either forward or backward. Depending on the design of your robot, the in dir variable will make your robot go in one direction when true and the opposite direction when false. The final variable to initialize is in steering, which is a number which will initialize to 0 in order to make the robot move straight, as opposed to in an arc. Now that all the input variables of our pre-MyBlock have been initialized, the next step is to pass these values into our actual MyBlock inputs. We do this by reading from the 4 variables with the in prefixes and writing these values to the 4 variables with corresponding names that don't have the in prefix. I'll need 8 variables for this, so let me put them on the screen now. You can duplicate a block by hitting the Control key and clicking and dragging the block to be copied. The first 4 blocks should have their action set to read, and the second 4 blocks should have their action set to write. The 4 variables with the in prefix should be read and written to their 4 corresponding counterparts using wires. If you align the variables symmetrically, it looks nice when you make the connections. In steering should be written to steering by connecting them with a wire. In power should be written to power. In dir should be written to dir. And in distance should be written to distance. So after all that, we've created a nice symmetric pattern where all the variables with the prefix in are in a group on the left, and all the variables without the prefix in are on the right. The reason for this is that when we create the MyBlock, we select only the variables that are being written to, and the dangling wires are what tells the NXT-G program to create inputs to the MyBlock. I realize that there are other ways to do this, but this is a very general and clear method to create MyBlock inputs, so I recommend using it even though it's a bit tedious. Now let's initialize the two variables needed to do the mathematical calculation that will convert the distance into a number of degrees to run the motor. The first step is initializing the wheel radius variable with the wheel radius in millimeters. Our robot TubBot uses wheels with a radius of 40.5 millimeters. It's a bit difficult to get an accurate measurement of the wheel radius, especially since most Lego wheels are a bit mushy. Because of this mushiness, the radius of your robot's wheels is likely to be slightly smaller than what you measure when the robot is in the air. After measuring your wheel radius as best you can run the robot for a meter and then use the actual distance it traveled to help tweak your wheel radius to a more exact value. Anyways, here I'm going to write the value of the wheel radius with a value of 40.5, which is what we have found works well with the wheels we use on our robot, TubBot. Next, let's define the constant C180 over pi to its value of 180 divided by pi, which is 57.296. Since 180 and pi are both constants, we combine them into a single variable called C180 over pi to save a little memory and calculation time. We could have used an NXT-G constant block for this, but a variable block will work fine too. Now let's implement the math formula presented earlier. I'm going to start by putting down a math block under the data menu, set to multiply. Just to the left of it, I'll set down another math block, set to divide. According to the formula, we need to read the C180 over pi variable and wire it into the port A of the division block, which sets the value for the numerator. Next, we need to read the wheel radius variable and wire it into port B of the division block, which sets the value for the denominator. Next, we take the result and wire it into the multiply block. We'll use port B to prevent wires from crossing. Then we'll read the distance variable and wire it into port A of the multiplier. Finally, we'll wire the result of the calculation into the duration port of the move block. This completes the calculation of the number of degrees to rotate the motor. We're almost finished. The remaining steps of making the pre-MyBlock are just connecting the remaining 3 inputs to the corresponding ports of the move block. I'll start by dropping down 3 variable blocks just to the left of the move block. To avoid crossing wires, the variable block closest to the MyBlock should be direction. The variable block in the middle should be steering. And the one on the left should be power. Next, I'll wire up the variables with their corresponding move block inputs. The direction variable is wired to the direction input of the move block. The steering variable is wired to the steering input of the move block. Finally, the power variable is wired to the power input of the move block. I'd like to emphasize one important point that might not be apparent in this design, but is critical to making your MyBlocks work. Observe that we have not used any of the variables with the in prefixes in any of our calculations. This is very important. After making the MyBlock, the pre-MyBlock variables with the in prefix will not exist in the MyBlock. If you accidentally used any of these variables with the in prefix in the part of the code that will make up the MyBlock, the variable would be undefined and the MyBlock would not work properly when it was generated from the pre-MyBlock. We're getting close to the point where we actually generate the MyBlock, but before we do it, it is very important that we first test the pre-MyBlock and then back up the pre-MyBlock file. For some reason, NXT-G will completely trash your pre-MyBlock when you make the MyBlock. It will rename your ports, it will move your comments so they no longer line up, and it will replace your programming blocks within the MyBlock. This is very frustrating, and it is a really annoying feature of the software. If you made a mistake in your MyBlock, or if you found yourself wanting to add an input or an output, your original pre-MyBlock would be gone forever. You'd have no way to add an input or output to the MyBlock once it was trashed by NXT-G. So therefore, it is in your best interest to save a copy of the pre-MyBlock before generating a MyBlock from it. So, after a lot of frustration and trial and error, our team, with the guidance of our coaches, has come up with a recommended procedure for making MyBlocks. First, test your pre-MyBlock thoroughly to see that it works by downloading it to your robot and running it. The most important thing is to test that all of the inputs of the MyBlock function correctly. For logic inputs, test with both true and false values. For number inputs, test with a couple of different numbers. You do this by changing the initial values written to the variables with the in prefix at the very beginning of the pre-MyBlock. As an example, we're going to test our pre-MyBlock by downloading it to our robot and running it. If it works properly, it should move forward 1 meter. Okay, let's see if it works. After testing your pre-MyBlock, the second step is to save it and close the file and exit NXT-G. Then, make sure that you use your computer's operating system to copy the pre-MyBlock to a file with a different name. This is in case if one of the next steps goes wrong, you can always recover the original pre-MyBlock. The third step is to open your pre-MyBlock in NXT-G and select the part of the pre-MyBlock that will become the MyBlock. Here's how you do that. Go back to the beginning of the file and start highlighting from the part just after the last variable block that has an in prefix. The wires that bridge the included and unincluded part is what tells the NXT-G to form input ports. So highlight from that point all the way to the back of the MyBlock. Now, under the Edit menu, select Make a new MyBlock. Type the name of our MyBlock, which is Go Distance, here. Then click Next. Now you can select an image to associate with the MyBlock. Since this MyBlock is essentially a glorified move block, I'll select the move block image as the image. Finally, click Finish and your MyBlock will be created. You can see that the group of blocks was replaced by your new MyBlock. Okay, the fourth and most important step of all is to exit NXT-G without saving GoDistance_pre. We went through a lot of trouble making our pre-MyBlock, and it is really terrible that NXT-G trashes it. If you had put comments, they would all be misaligned now. So exit NXT-G and do not save your pre-MyBlock. Don't worry, your MyBlock has already been created in another directory and is safe and sound and ready to use.